Hey guys, in today's video I'm going to show you how to hook up your Smaart software to a very simple digital audio interface. So this digital audio interface is just connected via USB. So I got a little USB cable on the side there and it plugs into the back of this. So now Smaart can see what's happening in this device. This device is essentially a little mixer. It allows inputs. So I have different things that I can input, and then it allows on the back outputs. This one does 4 and 4, so 4 in, 4 out. Now, the way that I have it configured is I have inputs number 1 and 2 there are just two different microphones. They are the Dayton EMM6. This one is serial number 10951. It's one of the ones that I use. The other one that I use is sitting over here, just pointing out into the room, and that's 10282. So we'll see more of that in a second. So both of those microphones are plugged into the inputs here. And then from the output of this, it is going to the input on my board on channel number 31. Right there. So that's going to be a pink noise input from this. That pink noise is being sent from the Smaart software. So I'm generating pink noise in my laptop. It's going into this device, my digital audio interface. It's going from the output into channel 31. Now, the way that I have my routing done on this is that channel 31's pink noise, I'm going to select it, goes to both the stereo bus and to the mono bus. So let's take a look at that. Over here is my stereo bus and my mono bus. My stereo bus, if we look at my bus routing, my stereo bus is sending to matrix 1, 2, 3, 4, and 5. So everything that I send into my stereo bus goes to channels 1 through 5, which are a D&B system for my main line array on my left, a KLA system for my center fills left and right, a D&B line array for my right hand side, and my center fills, but not over to my subs. So it's not going over to my subs from the stereo left and right. If I click on the MC, which is my mono bus, looking back over at this, you'll see that channel 6 is getting anything that's being sent to my subs. Okay, so that's making it to here. So I send my pink noise from the laptop into channel 31, out of channel 31 into my stereo left and right and my mono bus, and that then sends it to all of these matrices. Now these matrix channels are a D&B line array that's up there in the corner, my center fills left and right, and then on the other side of the room I have another D&B line array sitting way over there. On the stage I have some center fills, you can see down there, and then behind either screen, on the far right hand side of this screen and the far left hand side of this screen, are subwoofers kind of hiding behind the curtains. So that's the speaker system that I have, and that's what I'm sending my pink noise to individually. So let's look at the routing. Try to give you guys nice views so you can see exactly what it is I'm doing here. On Smaart, I go over to my config and then my in-out config, my IO config. This little dialog box comes up and it's going to show what I have connected. Okay, so you can see that I have my Behringer UMC 404 HD, and it is currently connected, so it sees the USB input from that. And I also have the internal generator, which is how I can send pink noise, white noise, 1K tones, whatever I want, okay? So on the input devices, we're talking about this now. So now we're going to tell it what these inputs are. Input number 1 is that serial number microphone, 10282. So that's the one that's in the room, and that shows the signal that that microphone is just hearing in the room. Input number 2 is the microphone on the desk in front of me, that's 10951. Here's the input there. So if I adjust the gain volume on the front of this guy, so I'm just going to adjust the gain for the microphone that's right in front of me, you'll see that that signal just keeps going up. I can clip it, get it really strong, right? So that's how you adjust that microphone gain. is just by the UMC 404. And remember that it supplies phantom power that these microphones need. Now the last thing that I have here in my inputs is a loopback reference from the mixer. And this is the important part of doing transfer function. So on bus number 6, I have a pink loop output, okay? So everything that I'm sending into here, I'm also sending to this bus output. So this bus output coming off of the back of the mixer there, channel 6, is going to go into channel 4, okay? So now I can get signal back from the mixer into this device so that Smaart can compare data, okay? So that's the input side of this. The output side of this is I'm using the UMC 404 HD. I'm only using one channel of output because that's all I really need. And that output is right here, and it's just used for sending pink noise into channel 31. Okay, so you can see that there's a light signal present there. Its volume is up, but I have all my matrices outputs muted, so I'm just going to go through them and unmute them really quickly so you guys can hear. There's my main line array on the left hand side, center fill left, center fill right, and those are the ones that are flown up in the air. There's the D&B system on the far right hand side, the center fills on the stage. I don't know if you can hear that one, but that's my subwoofers behind the screen. So now I'm sending pink noise to any single channel that I want, so I can send it to any individual speaker and then measure it. So this is what we're going to do. I'm going to go turn on, well, let me explain a little bit further here. So, you guys have a good understanding about how that routing is done. Let's close this window and look at transfer function window. This is where you do measurements to get the time that it takes for not only the laptop to process the audio, but the digital interface to process the audio, the analog console to process it, the time it takes for the microphones to see it. And then this here is the phase, so it will show you the phase squiggle of how the phase trace is looking when it comes back. This is coherence, or how well it's interpreting the data that it's hearing. And over here, this light green line, which is sort of dead right here, this is going to be the magnitude or the strength of that signal as it comes back. Pardon me. So how does it all work? Let's go over to shortcut my RTA. My RTA is my pink noise generators. So that microphone in the room, that's what this currently sees, is that. The microphone right in front of me, as you can tell, is picking up my voice right there on that blue line. The loopback reference is the output, the pink noise output, as it's coming back into the system, and then directly the generator from the laptop. Okay, so those are the different things that I can see. So if you look at this pink noise generator, you can see that the signal, for what it's worth, is flat. It's what they kind of consider just to be a perfect signal. So because Smaart is sending this out, it understands what it's looking for when it sees the pink noise. Okay, it now can compare the signal that it's sending to here into the mixer and then back out into channel 4 and can compare it against these two microphones. So obviously I have two different signals, one that's coming from the board, that's a true reference, and then one from the microphone. Now I can compare those two. So what it's doing is I'm sending out pink noise into the sound system, which is perfect. If it was a perfect room, an anechoic chamber, then the sound that I got back from that microphone would look exactly like this. It would just match up line to line. No such thing. No perfect world. No free lunch. So what we're doing then is we're going to compare the difference between what Smaart is seeing as the signal that it's sending out, the signal that it's getting back from the mixer, and what it's comparing it to, which is the microphones in the room. So let's do, back to the transfer function. So let's do a quick measurement. I'm going to show you how to set this up. So I just have live versus room. So let me explain what this is. In order to compare these things, we need to tell it how it's getting its information. We're telling that it's looking for this device, the UMC 404HD, and that's going to be the measurement signal. And we're measuring 10282, which is the microphone that's sitting in front of the tech table here. The reference signal that it's using to compare the measurement and the reference is going to be my loop back. So my loop back is just that bus output coming back into channel 4 here. So now it goes, okay, I'm comparing this to this, right? So even though I have kind of a complicated setup on the X32, it's really as simple as saying, okay, my pink noise output on a Mackie mixer is just going into channel 1. I can send that out into a speaker off of left, and then the right channel on a little Mackie I would just send back into here, and then I just compare what is it seeing from the microphone, what is it seeing from the mixer. That's all there is to it. This will give you a ton of information, including time, coherence, magnitude, phase. Let's close this guy out. So the first thing that I want you to see is that there is no time information on this window. So what I'm going to do is I'm going to use a speaker that's fairly close to me, that's center fill left, and I'm going to turn it on, and we're going to take a look at what this does. Okay. So from this, I can adjust my microphone sensitivity, which is my measurement channel. So you can see I can bring it up really high, bring it down really low. Let's get it on that second line there. Get into focus. There we go. And then the other one that I have is the input from channel number 4. I can adjust him, and I can increase or decrease the input that's referencing. So we're just going to try to get those two to lock together, about the same input and output reference. So right there, nice good strong signal. But there's no information for time. So if you look up here, it's got no reference for time, so it's just looking at the phase of the room, the magnitude of the room, and the coherence. So watch what happens when I come over here and I turn on the essentially the auto tracker for time delay, and we're going to look at him and what's happening in that upper window for the impulse response. It locks in at 50.56 milliseconds, and that's what it's looking at. So when it sends out pink noise, this is what it sees. It sees this time spike that it can use to give me more data. I don't need to keep scanning him, so I'm just going to lock it in place by turning him off. Now we have a reference in time. So with that now, we can look at the phase of the speaker as it sits in the room at this distance, and we can look at the magnitude, or essentially the strength of all the different frequencies as it's coming back to me. So it's sending out a perfect signal, and this is what it's hearing when it comes back. And it can now separate all that data and say, well, this is what I hear more or less from what you're sending out. This is the phase or the time wrap of the signal that it's sending out. And here's the exact amount of time that it's taking for me to reference these things. So if I were to now move the microphone, you would see this phase trace change, you'd see the magnitude change, you'd see the time change. So that's what there is to setting up these systems. I'm going to go ahead and mute him. So it's kind of hard to explain this stuff. It's a complex thing to set up. I hope these videos help people out in at least getting their head wrapped around how to get any of the software, be it REW, be it Smaart, any spectrum analysis software that does transfer function, and just understanding how to interpret the data and more importantly, just how to hook it up. So even that is a good start, and I hope this video helps you. So little digital audio interface that just USBs into my laptop so we can see the audio. 2 microphones, one of them at the tech table, one of them sitting in front of the drape line there. The reference back from the mixer, so it'd be the equivalent of just sending the left output back into this, and then a way to get the pink noise into that system to begin with, which is just the output on the back that goes into your mixer. So I hope in a consolidated kind of version this helps you guys out and in understanding how to hook it up now with a digital audio interface rather than a digital console that may have a digital card built into it that sends the audio out. So in this scenario, this mixer doesn't even matter. I could have done the same thing with a 1 input and 2 output Mackie. Would have been pretty much the same thing. So let me know if you guys have any questions on integrating this into your system. Oh, in case you're wondering, the Behringer UMC 404 HD on B&H Photo is like $100. These microphones, the Dayton EMM6s, cost like right around $75 on eBay. So these 2 components of the system are fairly inexpensive. It'll work on all the analog boards that you're using. So if you have a little Mackie, a Soundcraft, a Yamaha, something that's just analog, this system will do it too. It doesn't all have to be digital. You just need a way to communicate the data back into your laptop so that it can interpret what it is that it's hearing. It knows what it's sending, compares it to what it hears, and that's how you get this information. So if you have any further questions, let me know, and I will hopefully catch you guys on the next one. Thanks so much for watching.